Hello friends, welcome back to Gradeup. My name is Vikas and today I am going to cover some previous year gate question on the concept of engineering mechanics. Okay, so far I have covered 10 video lectures on engineering mechanics in which I have covered all the topics or touch all the topics of engineering mechanics syllabus, okay, from the gate point of view. Now in today's video lecture I have also selected some few good questions that are related to all those concepts that I have covered in the engineering mechanics tutorial lectures. Okay. So let's solve some previous year gate questions. Now first question is from gate 2015 set 1. This was a question which is asked from the topic of trusses. Okay. In this question it is given that two identical trusses support a load of 100 Newton as shown in the figure. Okay, the length of each truss is 1 meter. Okay, so the length is given as 1 meter, and the cross section area is 200 mm square, and Young's modulus is 200 gigapascal. The force in the truss AB in Newton you have to find out. You have to find the force in this truss AB. So if you remember, I have told you on the concept of this forces or trusses, I have told you that there are two methods, either method of joint or section. But there was one more important method, that if you know the value of these forces, so you can easily find it by sine law. There was by sine law. As you can see, there are three forces, and the angle between these, if we somehow find the angle between these forces, okay, so you can easily calculate the unknown force. Suppose that this is AB, okay, this is FBC, and this is given to you 100 Newton, and this angle is given as 30 degree and 30 degree. Okay. Now if you somehow know these angle values, you can easily find it with the help of sine law, which is nothing but FAB over sine of, if this is FAB, so this opposite angle, okay, and this FBC over the opposite angle, and 100 over this opposite angle. Okay, so if this is 30 degree, so if this is the 90 degree, you know this will be 90 degree. Okay, the angle which this line will make you, it is 90 degree. So total angle will be equal to 120 degree. Similarly, this will be also equal to 120 degree, and we know that for this complete angle will be equal to what? How much? 360. Okay, so this will also be equal to 120 degree. So we can say that FAB, opposite side angle is 120. FAB over sine 120 degree will be equal to 100. This is 100. Okay, and the opposite angle is 120. So 100 over sine 20. Okay, so do I really need to solve after this? This will get cancelled out. FAB will be equal to 100. So this question was very tricky question and was asked in 1 marks, but this is very important that you have to use your concept. Okay, here you are applying two concepts. One concept is the triangle law, okay, in which you can find with the help of sine law you can find the value of unknown force. Other is the trusses. Okay, so you have to apply this concept to solve this question, and the answer is equal to 100 Newton.
Subscribe to our channel and press the bell icon to never miss any update from Gradeup.
Now this is again a question of truss which was asked in gate 2015 set 2. In this question it is given that this is a truss, okay, and you have to find the magnitude of force in member SR. This is the member SR, you have to find the truss. So I have told you that there are two methods of finding the unknown forces in a truss, method of joint and method of section. If you have to find the unknown force in a particular member, this is the member SR, and you have to find in this member, so you have to use method of section. Okay, if you have to find the forces on particular joint, okay, then you have to use method of joint. Now how you are going to find it? Firstly, you need to remove these unknown forces, these supports with reaction forces. Okay, so this support will be removed and there will be reaction force Rp, and here there will be reaction force Rq. Okay, Now what we'll be doing, we'll be applying the equation of balance of forces and balance of moment. Okay. Now since this is a method of section, here we can apply equilibrium of moment also. Had it been method of joint, then we can only apply this method of equilibrium of forces, not the method of equilibrium of moment. So here we can apply method of equilibrium of moment. So firstly we'll take moment about this point P. Why? Because we know the value of this 30 Newton force. So if we apply this moment P, okay, if we moment at P is equal to 0, because this is fixed here, okay, the total moment here at point P will be equal to 0, and this will be equal to, now here 30 Newton force is applied downward. If downward force is taken as positive, so this will be 30. Now the distance between this 30 and this distance, point P is equal to 2 meter. Okay, so 30 into 2. Okay. Now another reaction force is RQ. RQ, direction of the RQ force is opposite to this direction. So this will be minus times of RQ into the distance of RQ from this point is equal to 3. So into 3. So here you can get the value of RQ is equal to 20 Newton. Okay, so you got the value of RQ. Now you have to find the unknown force in this member SR. So firstly you have to, by method of section, you have to remove this complete section from this truss. So if you remove this complete section, so this will be equal to S, R, T, Q, and here there will be a force 20 Newton. Okay, this is 1 meter and this is also 1 meter if we see from this geometry. Okay. Now we have to find the unknown for FSR. Okay. So what we can do, this point, at this point, point T, if we apply the moment, so here there is no force, since there is no force acting at this point, so the moment at this point will be equal to 0, point T. Okay. So if the moment is equal to 0, that means the force Q, RQ into 1, okay, will be equal to FSR into, this is the perpendicular distance, so the moment will be equal to FSR into 1. So RQ value, you know, this is RQ is equal to 20, so 20 into 1 will be equal to FSR into 1. So from here you can get the value of force in member SR, which will be equal to 20 Newton. Okay, so this was a method of section. Here you question of truss where you have used method of section to solve the or find the unknown force. Okay, so remember, if there is a method of section, you can apply the equilibrium of moment, and if it is a method of joint, or you have to find the force at a given joint, then you will be applying equilibrium of forces. Now this is a question from GATE 2015, set 3. In this question it is showing that figure shows a wheel which is rotating about O2. So this is a central point O2, along with this is rotating. There is a wheel which is rotating, and 2 points A and B are located along the radius of the wheel having speed of 80 meters per second and 140 meters per second. Okay. The distance between the point A and B is given to you, which is 300. So this distance is equal to 300 mm. Okay. Now you have to determine the diameter of this complete wheel. Okay. So how we can find the diameter? If you know the radius of this wheel, you can easily find the diameter. Suppose the radius of the wheel is equal to R. Okay. Now, since this body is a rotating one, this body is rotating, so the angular velocity of this point A and B located along this center, located on the center point of this rotating body, will be equal. That is, angular velocity of A will be equal to angular velocity of B, which is because these 2 points are located along the center of this rotating body, so angular velocity will be equal. Okay. So we know that V is equal to omega R. Linear velocity is equal to angular velocity into radius. Okay. So angular velocity will be equal to V by R. Okay. So this will be equal to VA over R. Now VA is the velocity of at point A, and R is the distance, this distance from the center. If this is total is given to you R, and this is equal to 300, is equal to 0.3. okay, 0.3 meter. So this will be equal to r minus 0.3, okay, and for this will be equal to VB over r, distance from the center. You know the value of r? No. You know the value of VA? Speed of A is equal to 80 meters per second and B is equal to 140. So if you will put 80 over here and 140 over here, you will get the value of r, which will be equal to 0.7 meter. So radius, you have you got the radius of this wheel. So diameter will be equal to 0.7 into 2, which will be equal to 1.4 meter. Since it is asking value in mm, so this will be equal to 1400 mm. Okay, so diameter of this wheel is equal to 1400 mm. Okay, so the concept used in this question is that if a body is rotating, so the point which are located along the center of the rotating body, those points will have equal angular velocity. Okay, so this was the concept used here. Now this is a question from GATE 2016, and this question is based on the concept of friction. Okay, in this question it is given that a block of mass m which rests on an inclined plane and is attached by a string to a wall. Okay, so this was a block which is kept on an inclined plane and this is attached to a wall with the help of a string. Okay, and the coefficient of friction between the plane and the block, this plane wall and the block, is given as 0.25 coefficient of friction. The string can withstand a maximum force of 20 Newton. Okay, so maximum force that this string can withstand is given to you, which is 20 Newton. So this tension is given to you 20 Newton. Okay, now the maximum value of mass for which the string will not break and the block will be in static equilibrium, you have to find this. Okay, value of cos theta, this theta is given to you, so cos theta and sin theta is given, and also acceleration due to gravity is equal to 10 meter per second square. So how you are going to find this value? You have to draw the free body diagram of this body. Okay, so here this is connected with the string, so there will be a tension force. Okay, and mass m is located here, so from center of gravity this will be m. This angle is theta, so this will be equal to theta. Okay, so this will be equal to mg of cos theta, and this component will be equal to mg of sin theta. Okay, and there will also be a normal reaction acting in this direction opposite to this mg cos theta. Okay, now since this body will be moving in this direction, there will be a frictional force acting in this opposite direction of motion. Okay, so what you have to do, you have to apply the equation of equilibrium of x direction and y direction. So from the equilibrium of forces in the y direction, n normal reaction is equal to mg cos theta, n is equal to mg cos theta. Okay, so normal reaction will be equal to m, you don't know, g is 10 and cos theta is 0.8, so this will be equal to 8 into m. Okay, n is equal to 8m. Now if we apply equilibrium of forces in the x direction, so this will be equal to mg sin theta minus t minus frictional force, okay, equal to 0. Now this tension is given to you 20, this is given to you 20 Newton. Okay, and frictional force is equal to, you know that frictional force is equal to mu into the normal force. Mu is given to you 0.25 and normal force, you know, it is equal to 8 into m into 8m. So after putting the value of frictional force tension in this equation, this will give you mg of sin theta is equal to 20, okay, plus mu, that is 0.25 into 8 into m. Here m is not given, g is 10 and sin theta is 0.6 equal to 20 plus 0.25 into 8m. After solving it, this equation, you will get the value of m is equal to 5 kg. Okay, so the answer will be 5 kg. Okay, so this was simple question in which you need to resolve this component and you have to find the value of you have to apply equilibrium of forces. Okay, now this is a question from GATE 2017 set 1. In this question it is given that two discs A and B with identical mass m and the radius r are initially at rest. Okay, they roll down and from the top of an identical inclined plane without slipping. Okay, disk A has all of its mass concentrated at the rim, while disk B has its mass uniformly distributed. At the bottom of the plane, the ratio of velocity of center of the disk A to the velocity of center of disk B will be. So this is the case. Suppose this is the inclined plane and the body is rolling down without slipping. A and B, there are two bodies A and B which are rolling down this plane. Suppose this height is h. Okay, they are rolling down this plane. Okay, now what will happen if some body is falling from some height? Okay, so initially it will have some potential energy, but as soon as it will fall from this height, this potential energy will be converted into kinetic energy. Okay, and for kinetic energy of this body A will be equal to kinetic energy of body B. Okay, because they are falling from the same height. Okay, now this kinetic energy of body A and body B will be sum of the translatory motion kinetic energy and the rotatory kinetic energy. Okay, because this body along with rolling, this will also slide down this plane. It is pretty obvious it will also slide from this plane. Okay, so the total kinetic energy, translated kinetic energy will be equal to half VA square, and total rotational energy will be equal to half IA into omega A square. Okay, now similarly for this it will be equal to half m VB square plus half IB into omega B square. Okay, so this is the concept used here. Now what you have to do is, we know that first you need to find the value of moment of inertia of this body A and body B. So moment of inertia of the body A, since the mass is, it is given that the mass is concentrated at the rim in the disk A. So the moment of inertia for disk A will be equal to m r square. Okay, because it is a concentrated mass. Okay, so the moment of inertia will be equal to this. And for this second disk B, it has mass which is uniformly distributed. So the mass moment of inertia for this will be equal to m r square by 2. Okay, so after putting the value of moment of inertia of A and B in this equation, okay, we can easily find the value of ratio of VA over VB. That is you have to find. So after solving it, this will come out to be root 3 by 4. Okay, so this is the trick that you have to use. And I also told you that the moment of inertia of particle A, body A and body B will be this. So you just need to put these values over here. And next thing is that you will get the value of this ratio of velocity of A and velocity B. Okay, which will come out to be root 3 by 4. Okay. Now next question is from GATE 2018 set 1. In this question it is given that a bar of uniform cross section and weighing 100 Newton is held horizontally using two massless and inextensible string and as shown in the figure. Okay, so this is given here. There is a rigid support and there are two strings which are supporting this mass weighing 100 Newton. So since this is 100 Newton weight, so weight will be acting at the center point of this bar and this will be acting downward. Okay. Now what you have to find? You have to find this unknown tension in this string, okay, which is being supported by this rigid support. So how we are going to find it? Firstly, we will see here, this bar is attached over here. Okay, so this is fixed from this point and this can rotate or have rotation motion along this direction. Okay, so firstly we will apply the moment at this point. Suppose this point is A, okay, and this is B and this is C. Okay, so applying moment at this point at A, the moment will be equal to 0. So if we see moment is equal to force into distance, so this here force is equal to 100 Newton. So 100 into distance is L by 2, and there is also a tension force acting upward which is opposite to this direction. So this will be equal to T2 into, and the distance is equal to L by 2. Okay, so after solving it, we will get T2 will be equal to 100 Newton. Okay, now second equation that will be applied is equilibrium of forces. Okay, so from equilibrium forces, net tension acting upward will be equal to this weight, which is 100 Newton. Okay, you know the value of T2 is equal to 100, so this will equal to T1 plus 100 equal to 100. After solving it, you will get T1 equal to 0 and T2 is equal to 100. So out of given option B is the correct answer. Okay, now this question is from GATE 2018 set 2. In this question, it is given that a force of 100 Newton is applied to the center of a circular disc. Okay, remember it is a circular disc of mass 10 kg, okay, and radius is 1 meter, resting on a floor as shown in the figure. If the disc roll without slipping on the floor, then the linear acceleration of the center of the disc is, you have to find the linear acceleration. Okay, so how we are going to find it? We know that since this is a case of a disc rolling without slipping, so firstly we should understand if it is pure rolling, then for a motion in a pure rolling condition, torque equation is given by torque is equal to I into alpha. Okay, because it is a case of rolling, pure rolling case. Okay, now torque is equal to force into the distance, perpendicular distance. So this is the force which is acting at the center of the disc. So the perpendicular distance is equal to the radius, and this radius is given to you, which is 1 meter. So torque will come out to be 100 into 1, which will be equal to 100 Newton meter. Okay, so this will be the torque which will be acting at the center of this circular disc. Now, what will be the moment of inertia? The question, what will be the moment of inertia? So the moment of inertia for this rotating rolling circular disc will be equal to mr square plus mr square by 2. Okay, it will be the sum of mr square, which will be the mass moment of inertia, plus the moment of inertia of this disc, circular disc, which will equal to mr square by 2. So total moment of inertia will be equal to 3 by 2 mr square. Okay, for this circular disc at the center. Okay, now we know the value of m is given to you 10 kg, r is equal to 1, so you can easily find the value of this. I will be equal to 15. Okay, you know the value of torque, you know the value of this, so you can easily find the value of acceleration. This will equal to 100 equal to 15 into alpha. Alpha will come out to be 6.667, okay, radian per second square. Okay, is it clear to you? So this was a very easy question, but what you need to apply? You need to apply the concept of, since it is given that if a disc roll without slipping, so it is a case of pure rolling, and we know that from kinetics, equation of motion for pure rolling condition or rotary condition is equal to torque is equal to I into alpha. Okay, which is analogous to equation F is equal to ma. Okay, so torque you have find out, you know the value of moment of inertia, so you can usually find the value of acceleration. Okay, so this was a good question. So value of acceleration is equal to 6.667 meter per second, radian per second square. Okay, is it clear to you? So this is all for today. Today we have solved previous year GATE questions on the topic, some important topics of engineering mechanics. Okay, with this I completely cover my complete syllabus of engineering mechanics along with the previous year GATE questions on this engineering mechanics subject. Okay, I hope you have gone through the video lectures and have practiced numerical on your own. Okay, the one thing that I want to tell you, that of all the topics which are given in the GATE syllabus, you just need to revise those topics. Don't waste your time because it is just of 2 marks, but you have to revise all the topics, because if you not have idea about all the concept, you won't be able to solve the question because you don't know which concept will be applied to a given question. Okay, so you have to revise all those concept and all the topics, and then you just need to practice more and more numericals on engineering mechanics. And you can also join test series. First thing is that you should join test series and where you can get more new question, from where we can apply your mind and you can apply more concept. Okay, and you can also revise your concept by solving the question given in the test series. Okay, so this is all for today, and practice for your GATE exam. And if you have any query, you can post a query or comment on the Gradeup app. So thank you. Have a nice day.